Good afternoon, everyone. Thank you so much for joining us. My name is Katie Rowley, and I will be the host today from the NOAA Central Library. We are using GoToWebinar with this webinar platform. If you are having any trouble with the audio or the visual components of this webinar, please try logging off and logging back in. That solves most issues. Please know that we are accepting questions for this seminar, but the questions will be held until the end. So feel free to place them in the question/chat panel throughout the seminar, and we will grab those after everyone has spoken in the Q&A period. And with that, I would like to welcome you all to the Powering the Blue Economy Ocean Observing Prize overview. We scheduled this several times and are very, very happy to finally be presenting it. Our speakers today are Michelle Harris. And Michelle Harris is a Knauss Fellow with NOAA in the Integrated Ocean Observing System Program Office within the National Ocean Service. And prior to her fellowship, she completed a master's in geography from the Wind-Induced Nearshore Dynamics Lab at the University of South Carolina, where she focused on coastal and aeolian geomorphology, remote sensing and GIS, and coastal management. Our second speaker will be Carrie Schmaus. She is a Marine Renewable Energy Technology Manager at the U.S. Department of Energy and a 2018 Young Professional Leader at the International Electrotechnical Commission. Before spending 2.5 years with WPTO as a NOAA Knauss Fellow and ORISE Fellow from 2018 to 2020. She worked as a research fellow at the National Council for Public-Private Partnerships. Her master's is from the School of Marine and Environmental Affairs at the University of Washington. Our third speaker today will be Charles Scaife. He is a 2020 Knauss Marine Policy Fellow at the U.S. Department of Energy and a PhD candidate at the University of Virginia. Before coming to DOE, Charles conducted extensive research across Appalachia, quantifying the impacts of climate change on forest and water resources. He also received a master's degree in geography from University of North Carolina at Chapel Hill and graduated with a degree in environmental sciences and marine sciences at UNC. Our fourth speaker is Rob Cavagnaro. Rob is a mechanical engineer at the Pacific Northwest National Laboratory, where he leads the marine technical team at the Marine and Coastal Research Laboratory, and a senior engineer at the Applied Physics Laboratory at the University of Washington. His research focuses on engineering marine energy systems to power blue economy applications. Rob's PhD is in mechanical engineering from the University of Washington. And with that, I'm going to turn it over to our first speaker, Michelle Harris.
All right, thank you so much, Katie, and thank you all for tuning in today. Like we said, we have rescheduled this, and we appreciate you guys following through and attending this afternoon. So without further ado, I am really excited today to introduce the Ocean Observing Prize, which is a joint initiative between the Water Power Technologies Office at the Department of Energy and the Integrated Ocean Observing System, or IOOS program office within NOAA NOS. This prize does seek innovators to integrate marine renewable energy with ocean observing platforms and came to life really in 2019 after some initial scoping in 2018. In the fall of 2019, we did launch the first competition, which was called Discover, and it closed out in April of 2020, which some of you may be familiar with because we did recruit quite a few NOAA reviewers for that stage. So thank you to those that did participate. And then earlier this week, we announced the second competition known as the Develop competition. As the rest of our team today will describe, this competition does incorporate a single theme focusing on buoys and autonomous systems with a research focus on enhancing hurricane monitoring and forecasting. Now, this initiative does closely align with the NOAA science and technology focus areas, with an example being the NOAA Uncrewed System Strategy. So this competition does enable the collection of valuable data while also accelerating the commercialization of marine energy systems. I will now happily pass it over to Carrie Schmaus, who will provide an overview of the competition.
Thank you, Michelle. It's always a pleasure to work with you and the IOOS team. And I'd also like to extend a big thank you to Katie and the NOAA Library Seminar Series for hosting us, especially amid our many rescheduling. So we really appreciate it, and we're really happy to be here today. I can't help but remember my first time on the seminar series was actually as a Knauss Fellow, where I talked about the beginning of some of this work. So it's really kind of full circle for me today. As Katie mentioned, my name is Carrie Schmaus, and I started at the Water Power Technologies Office as a Knauss Fellow, but I'm there now as a technology manager. Today, I'll discuss the Powering the Blue Economy initiative, as well as go through the Discover competition of the Ocean Observing Prize, which, as Michelle mentioned, has already closed. And then I'll tell you about the Develop competition, which is newly open as of Monday, so we're really excited about that. Charles will then discuss sponsorship and partnership opportunities, as well as agency engagement. And then Rob will dive into some of the technical work and research regarding marine energy's role in powering ocean observing systems. Finally, of course, we'll end with some questions. And as always, don't worry if we go through a slide too quickly, because this is being recorded and will be available shortly. All right, getting started with the Discover competition. That was the first phase of this prize, but before we go into that, I just wanted to provide some additional background on how this work started. The Water Power Technologies Office at the Department of Energy focuses on advancing marine energy devices, which are systems that convert the energy contained in ocean wave, tidal, current, ocean current, river, salinity, or thermal gradients into useful energy. Much of our work at Water Power in marine energy is for the non-grid, smaller scale applications, really started with the writing of the Powering the Blue Economy report, which investigates opportunities for marine energy to power various near and offshore activities. And you can see the report is linked there. Ocean observing is one of these opportunities, and you can find many others, including aquaculture, desalination, disaster recovery and relief in that report. But today, of course, we'll be focusing on marine energy-powered ocean observing devices, which on the next slide is how we are advancing the state-of-the-art of these through our Ocean Observing Prize. The high-level goals of this prize are to integrate marine renewable energy with ocean observation systems, add value to the blue economy, and accelerate maturation of the marine energy sector, ultimately resulting in a prize where participants can compete for a total of $3 million in prize money and in-kind incentives. Next slide, please. The entire prize has two competitions. So the first one was the Discover competition, which, as you know, has already closed. That competition challenged innovators to submit marine energy-powered devices across those 5 themes you see there at the top. Overall, our goal with this prize is to provide resources for competitors to generate novel concepts that integrate ocean observing technologies with marine energy systems, and then develop their ideas into a functioning prototype that will eventually be tested. We'll talk about that in a second, but first, on our next slide, I wanted to share some of the winners of our Discover competition. Our grand prize winner was CalWave, and between that group and the 10 other winners, we were really excited to award over $125,000. You can learn more about the winners on the first competition on our HeroX platform, which is our website. Next slide, please. But now we'll move into talking more in depth about the Develop competition, which, as we've said now a couple of times, just opened up on Monday. The focus of the Develop competition is to design, build, and test novel, wave-powered, self-charging, autonomous underwater vehicle systems that, with some refinement, would be suitable for a 6-month deployment in the Atlantic Ocean to monitor hurricane formation. The design stage of this prize is what opened on Monday, and it will challenge competitors to come up with a concept that can meet this mission. And this is really, really exciting work for us at DOE and at our partners at the national labs, as well as our partners at NOAA. And I know I don't have to tell this group, we've already seen this year that enhanced hurricane monitoring systems are a really clear need for the US. And a wave-powered device that can enhance our ability to predict the intensity of storms will really have a profound impact on coastal communities. So we're really pleased to be part of this effort. On the next slide, you'll be able to see the diagram of the Develop competition, which is made up of 3 contests: design, build, and splash. Again, the only competition that is open right now is the design contest right at the start, but the overall goal of the entire Develop competition is to enable collection of valuable new data, generate sufficient power from co-located marine resources, accelerate commercialization of marine energy systems, and importantly, grow a diverse community of innovators. The design contest opened a couple days ago and will close in mid-February. During this contest, competitors will design systems that use ocean surface waves as an energy source for recharging autonomous underwater vehicles at sea for the purpose of monitoring hurricanes in the Atlantic Ocean. We'll award up to 10 prizes from the total prize pool of $400,000, and the winners of this contest will go on to participate in the build contest. And so this one is really important. You do not need to have participated in the discover phase or the first phase of the prize to be eligible to compete in the design contest. So applicants new to the prize or even new to DOE or NOAA completely are absolutely welcome and encouraged to participate. The design contest allows 3 months to design systems that meet the system requirements, and submissions to the design contest will then be reviewed by a panel of experts in wave energy, marine robotics, and ocean science to assess design potential. On the next slide is a quick overview of the build contest, which will of course follow the design contest. We anticipate opening this contest sometime in April. Competitors that make it to the build contest will build a prototype of their idea and actually test it in a tank, likely sometime in September 2021. Winners of the $500,000 prize pool will go on to complete in a splash contest, which has an overview there on the next slide, and is anticipated to open in November 2021. This contest is going to be an at-sea test of the wave-powered autonomous vehicles for hurricane monitoring, and up to 3 winners will be awarded a total of up to $1.5 million. The test is going to last at least a week and will be in real-world conditions out in the ocean. As noted on an earlier slide, prototypes built during this competition are not really meant to be mature systems, but they should at least demonstrate basic functionality and potential for refinement into a commercially viable product, which I'll talk about in just a second. But first, I want to take a moment to highlight the new eligibility criteria for the prize. Please note, if you participated in the Discover competition, you are not guaranteed to be eligible for the Develop competition, as this criteria was developed since the Discover competition closed. Again, a reminder, you are not required to have participated previously, so all new competitors are encouraged to compete, but all these competitors will be subject to the new eligibility criteria. The new eligibility criteria requires that the registered competitor's organization is under domestic ownership and control. If this stipulation does or may apply to you, the option to submit an eligibility criteria waiver is available. We encourage registrants that may need a waiver to submit those as soon as they can, and to please reach out to us with any questions. To submit a waiver, the participant must, and I'll just quote from the language we have here, demonstrate to the satisfaction of EERE, which is Energy Efficiency and Renewable Energy, that's kind of the larger office the water power program is located in, that its participation, 1, has a high likelihood of furthering the objectives of this prize competition, and 2, aligns with the best interests of the U.S. industry and U.S. economic development. Again, we encourage folks to reach out if you have any questions at all. Please just send us an email at that email, which is wptoprizes@ee.doe.gov, and to please submit a waiver early if the registered competitor's organization is not or may not be under domestic ownership and control. Of course, more information on this can be found in the rules document, and again, I really encourage folks with any questions to please just reach out. Moving on to the next slide, we have an overview of some of our prize incentives. And so as I noted a couple of slides ago, the resulting prototype from the Develop competition is not expected to be a commercially viable product yet. We are really pleased to offer the incentives you see there on the left, which includes cash awards, of course, but also access to testing and validation, Blue Economy business webinars, mentoring and coaching, an investor pitch event, and opportunities for partnerships across all the different contests of the Develop competition. Our hope is that with these resources, competitors will have a solid foundation and will be able to develop a prototype that can be commercially viable in the future. The next slide has the link for our rules document. That includes full details on prize requirements, selection criteria, and eligibility and waiver information. So I encourage you to take a look at our HeroX page and read the rules. Finally, there are just a couple of next steps for you to get involved. The first thing you'll want to do is create a HeroX account, and then of course follow the Ocean Observing Challenge. From there, you can form a team, develop your idea. It's also important to know that we will be holding another kickoff webinar next week on October 28th, And information about that can be found on the HEROX site as well. And during that webinar, we'll get a little bit deeper into what it means to be a participant in this prize and some of the requirements and other details like that. Finally, just a reminder, the design challenge does close February 16th. So we really hope you don't waste any time getting started. This concludes the prize overview section of our presentation. So I'll now pass the floor to Charles, who is going to discuss some other ways to get involved in the prize. Thank you.
Thank you, Carrie, and thank you everyone again for joining today. At WPTO and at NOAA, we want all our prize competitors to be successful. However, we recognize that our resources can only go so far. So, as part of the Ocean Observing Prize, we've outlined a series of sponsorship opportunities for outside organizations to contribute to the success of our competitors and to the success of our prize. In the next slide, you will see that we're seeking to attract sponsors of the prize from all sectors. These sponsors can include nonprofits or NGOs, other state and federal agencies, investors, consulting firms, academic institutions, and even community organizations. There are several reasons to become an Ocean Observing Prize sponsor. And this includes things like a unique opportunity to engage communities across many sectors, including private and public, support for outreach and competitors and the prize, and to ultimately help accelerate wave energy powered technology innovation. Becoming a sponsor means being part of a network of innovators, technical experts, academics, industry professionals, incubators, and investment partners. And as a thank you, your organization's name and logo will be displayed on our prize webpage, appear in promotional materials, and be included in a list of partners. Next slide. We've outlined two main ways to get involved with the prize. The first is our Breaking Waves Outreach and Amplification sponsor. The primary objective of this sponsorship level is to amplify the prize. You can do this by helping DOE spread the message. Support can include blog posts, social media engagement, inclusion of the prize in your newsletters, or other amplification mechanisms that might be best for your particular organization. Some examples also include disseminating communications related to the Ocean Observing Prize and the identification and outreach of new and existing stakeholder groups. And as a thank you, we've outlined 4 main ways in which we will recognize your sponsorship at the Breaking Waves level. This includes the inclusion of your organization in social media posts and promotion, the appearance on our American-made challenge website, the HEROX website, and the WPTO website. The second way you can get involved is through our Surging Wave sponsorship level. The primary objective of this sponsorship level is to assist competitors preparing for the design, build, and splash contests. Support in this sponsorship category may include things like mentorship, prototyping support, or other services and trainings that could directly benefit all our prize competitors. Some specific examples could be things like design consultation to mitigate risk and improve survivability, simplicity, or efficiency. Or, for example, off-the-shelf components that would support competitors with building their systems. And lastly, trainings in the form of webinars to understand things like standardization and scaling design principles could also be useful. In addition to your sponsorship support, we would offer a feature in our WaterWire newsletter and a feature in press releases and, of course, specific branding of any offerings. Next slide. If you're interested in getting involved and becoming a sponsor of the Ocean Observing Prize, please contact us at WPTOprizes@ee.doe.gov. Next slide. We also want to note that beyond sponsorship from outside organizations, we are always open to partnering with other federal agencies to explore opportunities beyond the Ocean Observing Prize. There's a ton of ocean work out there, and we want to recognize that we're not the only ones working in this space. I don't have to tell this group, but there are equities across many federal agencies, and there are just a few of them listed on the left. At DOE specifically, we have equities across many spaces, including distributed small-scale energy, grid-scale production, and water security. We also have over 70 water projects worth over $150 million and range from Earth system science, maritime fuels and energy storage, and of course, ocean policy. Now, I'll turn it over to Rob Cavagnaro to talk about just 2 examples of these projects specific to ocean observing. Thank you.
Thanks, Charles. Next slide, please. Again, my name is Rob Cavagnaro. I work at the Pacific Northwest National Lab as a mechanical engineer. And my main focus is on marine energy technology. And today I'm going to give you a brief overview of what we call the foundational research and development process for marine energy integration into ocean observing systems that's parallel to, but also informs and is informed by the prize that Carrie and Charles talked about today. So we'll just get right into it. So in order to be more effective as we develop marine energy systems for ocean observing missions, we're conducting this foundational research and development process with the goal of improving the availability and acceptability of marine energy as a source for users in the ocean. And it's a multi-step pathway that starts by identifying near-term use cases with high potential value for the use of marine energy. We did a lot of outreach, and based on feedback from a series of interviews and surveys we conducted, we narrowed our focus on 5 generic platforms, though they're closely modeled off of existing platforms, some of which should be very familiar to this audience, that represent common observing missions and hardware that align with our respondees' existing use of ocean technology and the location in the oceans where they work. So our 5 selected use cases that we've done deep dives into are high latitude coastal weather buoys, high frequency radar installations, charging stations for autonomous underwater vehicles, deep ocean tsunami detection systems, and profiling or powering drifting profiling floats. Next slide, please. The first use case is modeled off something that should look very familiar. It's a high latitude coastal weather buoy. The one we're showing there is the NOAA SCOOP system. And the systems that we're looking at are self-contained ocean observing platforms that are designed for a 2-year operation. In the case that we're looking at, these are high latitude systems which have limited solar resources. It's one of the reasons why marine energy is promising at these high latitude locations is the limitations of solar. The systems that we're looking at should be serviced every 12 to 18 months. They're currently limited in terms of the power that's able to be generated, and they're typically used for atmospheric or oceanographic sensing, though additional sensing may increase forecasting capabilities and is a reason to look at more power for such systems. The specific location that we've cited this use case in is the station that's in Shelikof Strait, Alaska. That's the channel that runs between the Alaska Peninsula and Kodiak Island. And what we found through resource assessment of that area and first order modeling of what a wave energy system might be able to do in that environment is that a relatively small wave energy converter integrated with or near the platform could potentially provide enough power to increase sensing capabilities, so that the different types of sensors you can put on the platform, increase the sampling rate, communicate more frequently, or minimize the reliance on battery systems. We know that in a lot of these higher latitude systems, there's a separate backup battery bank whose primary purpose is to keep the rechargeable battery bank happy. So if we had more power available, there could be additional things we could do here. Next slide, please. The second use case that we've looked at is a high frequency radar platform in an area that does not have a connection to a utility grid. So these systems are generally used for measuring surface currents. They're used by a whole lot of different end users for search and rescue. Coast Guard uses it a lot, monitoring water quality. And these systems are serviced roughly every 6 months. In places where there is no grid connection, they would be either impossible or severely limited in terms of what they can do without power. The location that we've chosen to site this use case is also in Alaska, but this time in Cook Inlet, on the side of the inlet where there is no grid power available, but there is a strong tidal energy resource, that's a tidal current. This area was also identified as a critical location gap by IOOS, and we found that a relatively small, in this case 2.5 meter diameter tidal turbine with a small battery bank could provide enough power for such a high frequency radar station, increase its resiliency, and potentially allow it to operate more frequently. I'd also note that locations where tidal energy is strong, so strong surface currents, are also areas where you want to have good coverage for measuring those currents, and these high frequency radar stations are a good option for that. So there's a lot of overlap between the tidal energy resource and areas where this coverage would be beneficial. Next slide, please. The third and potentially most exciting use case for us that we've looked at is a prototype docking and charging system. The particular one that we looked at is for autonomous underwater vehicles and was prototyped by OOI at the Pioneer Array. And it consists of a surface buoy with small wind and solar generation capabilities, and it transmits power down its mooring line to a seabed-based AUV docking station. So we learned a lot from that team about the vehicle mission and charging cycle, the costs associated with running AUV missions from vessels, which is quite high, and many new opportunities that resident AUVs enables, and the various factors AUV power requirements depend on. So they noted that for this particular prototype, they were hoping to run a duty cycle where they would run missions for 2 days and then have a 5-day charging period. So there's large potential for avoided costs by having the charging happen autonomously. And the area that we cited this use case is at the site of the Pioneer Array. It's the Northwest Atlantic Ocean. In that site, there's a strong wave energy resource. And we found, analyzing that resource, that a small WEC supplementing other renewable resources has the potential to increase the range of the vehicles, decrease the operation costs by reducing the vessel and crew time, and increasing the utilization of the AUVs for various missions, including hurricane monitoring, which is, of course, the topic of the next round of the prize. Next slide, please. The fourth use case is modeled off the DART system. That's the tsunami detection and alert buoys. These currently rely on battery power. The highest power draw are the communications between the surface buoy and the seabed sensor, which is accomplished through acoustic modems, and then the satellite communications between the buoys and shore. These are deployed on a cycle between 1 and 2 years with 1-year service intervals for the surface assets. And these systems actually require quite low power on average. It's less than a watt if you consider the long time that these are out. But we do feel that there are opportunities to couple the surface asset, at least, with a marine energy system to have some redundancy on the power should the battery systems fail, and perhaps even automate some of the maintenance that will be done by a ship. This use case we also cited at the same location, the Northwest Atlantic Ocean, and we do find that a small wave energy converter near or at the buoy could provide enough power to add some extra capabilities to these systems. Next slide, please. And the last case is a little bit different from the other ones. We also took a look at powering drifting profiling floats similar to the Argo fleet. We note that these are battery limited, and at the end of the end of the charge of the batteries, the floats die and either end up at the bottom of the ocean or as floating debris. and approximately 800 of these a year are replaced at the end of their lives. And these perform a variety of sensing missions, but usually just temperature and salinity. But it's possible that they could also be used to measure current, pH, and a whole assortment of other measurements if they were not limited by power. So this use case we wrote as location agnostic because they're used throughout the oceans. And we did have a look at various ways of powering them, whether by wave power, tidal power, solar, salinity gradient, or thermal gradients. And we found that there may be some options to increase the sampling rate, increase the number of profiles, reduce their replacement interval, and enable additional sensing. And we know that there are commercial entities out there that are looking at thermal gradients and pressure gradients to power some of these floats. Next slide. So in summary, we're taking a look at this large range of fixed and mobile platforms that may benefit from integration with marine energy. And in the locations that we've cited these, the wave and tidal resources are the strongest. Of course, this is because we chose locations where we felt that there would be a high value proposition for integration with marine energy. But the common themes among the use cases included desire to increase the sampling and mission duration, that additional sensors could be put on these platforms if more power was available, and that there are avoided costs associated with less frequent maintenance and retrieval. So the next steps in the process were to refine the functional requirements. Those are the engineering requirements that would be required for marine energy systems to incorporate with these platforms, and then identify cross-cutting R&D needs. So now I'll shift gears and talk about that next step in the process. That's the functional requirements. And again, highlighting that foundational R&D process where the first step was surveying our end users. Then we selected those 5 use cases. The next step was to identify the platform mission, technology, power use costs, and the available resources, which I just discussed. Then the functional requirements are the things that a marine energy system must do in order to meet the requirements of those use cases, define constraints and barriers to that integration, and then design systems, subsystems, or components based on all of the above. Next slide, please. So to come up with these lists of functional requirements, we took another look at the use cases and added additional information through specifications of the hardware that's used on each of them. We went back to people who work on these systems and got direct feedback from users and designers. We used our professional judgment and experience, and we came up with a list of 20 distinct requirements and parameters to look at. Next slide. So no time today to go through each of these, but these are the list of the 20 parameters that we wanted to evaluate for each of the use cases. They include limitations on the size and shape of what we could put out with these observing systems, whether they're operating at the surface or subsurface or both, how much interference can they tolerate. That could be interference from electromagnetic sources or acoustic sources or motion. If we're allowed to add power systems onto the existing platform, or if they have to be separate, temperature range, device motion, but then 5 that I'll go into a little bit more detail on in this presentation. Next slide, please. Are having a look at the battery chemistry, the energy storage required for these platforms, and the power used in both the minimum or average and maximum and peak perspective. Next slide, please. So taking a look at the power requirements for our 5 use cases, I'm showing a few plots here that sort of summarize what we found. And we found that the power requirement is of course key to determining what kinds of marine energy systems will need to be developed to meet the current or existing needs, and then pushing these out to additional sensing capabilities. So we found that power ranges from milliwatts to almost a kilowatt, depending on the type of sensor. And then when viewed from the perspective of peak to average ratio, which is an indicator of system duty cycle, we found that the lower average power applications have the largest range of power levels required for operation. So that is, a lot of these systems run on very small hotel loads to keep the systems running, and then on very fixed duty cycles, we'll use a lot more power to, say, send an acoustic message or turn on the satellite and beam some data back to shore. So these factors are all critical to design efficient power electronics that can work across many different power scales for us. Next slide, please. We also found that battery type varies between the studied use cases. And for these 5, lead acid batteries were the most prevalent when recharge is currently possible. However, more and more of the systems are moving to lithium-based energy storage as barriers to maritime applications like performance and low temperature are being addressed. Looking at one of the use cases in detail, we surveyed a whole lot of different commercially available autonomous underwater vehicles in terms of their energy storage capacity and type of batteries used. And we found that there's a wide variety of things used, including fuel cells, and their capacities of these systems tend to increase with vehicle mass, as we'd expect. As the vehicles get larger, to move you need more power, but lithium ion is the most popular choice for the AUV application. Next slide, please. So the key findings of the functional requirements work is that we determined that there may be 2 classes of marine renewable energy systems that may serve most needs, and those are roughly at the 350 watt power range and then much lower at the 10 watt range. It'll also be critical not to interfere with the measurements that these platforms are taking by integrating marine energy systems. And we determined that acoustic communications and electromagnetic interference may be the most important, but also the motion of the energy system should not disrupt measurements. Certainly in cases like the coastal weather buoys, which rely on their own motion to measure waves, if we have an add-on wave system that changes how the buoy moves, that may affect how it measures waves. We also found that modularity drives size constraints. That is, if we are adding on power systems to existing platforms, they have to be small, and that may affect the buoyancy of certain platforms. And then the last key finding is we have to make sure that the systems that we're adding on are as reliable as small wind energy and solar systems, because a lot of these, or some of these ocean observations platforms already use these, and we have to at least meet the requirements for reliability of those existing sources of energy. Next slide. So just to conclude this, there are common functional requirements among these different use cases, and designing to those common requirements will increase acceptability and applicability of these marine energy solutions, but there may be some natural breakpoints in the requirements that generate different R&D pathways. So the type of energy system that you use with something like an Argo float is much different than what you would use for something like a coastal high-frequency radar station. And that the barriers to achieving these requirements are the targets for our research and development efforts at the national labs. So wrapping up, just like to thank you and then open up this, this entire presentation to questions.
Awesome. Thank you so much, everyone. That was really great. I'm going to let people put their questions in. Also, Carrie popped into the chat for everyone the link to the HEROES website and the official rules document in the chat if you missed that. Also, you can reach out to Carrie via her email, which is linked on this last slide here. So we do have one question that came in a little bit ago. Would you consider running a develop competition for tsunami early warning systems to be deployed in the Pacific?
Yeah, thanks. This is Carrie. I'd be happy to answer that question. I actually should have mentioned this when going through the prize overview, but the prize structure and with the Discover and the Develop competitions is actually intended to be repeatable. So we do sometime in the future intend to run additional iterations of this prize with a different focus area. And so certainly that could be something like tsunami early warning systems in the Pacific. So I'd like to kind of echo what Charles said, but if there are folks out there in the audience at NOAA or other agencies interested in a specific use case, like that was a really great example, I would encourage you to please just reach out to us, because we really would be thrilled to discuss how our priorities could overlap in a future prize.
Great, thank you for answering that, Carrie. I am not seeing any other questions coming in, but I'm going to give everyone another minute to think about them. And I have a quick question for Michelle, actually. How is NOAA's IOOS program involved in this? This is just my own personal interest.
Yeah, so we have kind of served as the liaison office for this prize. And I know coming on as a Knauss Fellow this year, I joined in February and quickly had boots on the ground assisting our office director with some of the initiatives associated with this prize. And we often are helping with the reviewer side of things, whether or not that's reaching out to our colleagues within NOAA and our other groups to see if they will assist with reviewing different applications, or getting the word out for this prize, and really just helping to promote it, and also kind of help shape the development of this next phase, and identifying those use cases that are relevant to NOAA priorities. And so discussing topics such as hurricane monitoring and how that can be useful for meeting those NOAA mission areas, our different areas where we're helping.
Great, thank you for that, Michelle. Okay, we do have one more question. Have you considered small fuel cells before for onboarding battery charging?
Sure, I can answer that one. So being funded by the Water Power Technologies Office, fuel cells directly are not something that we've looked at, but we do know that, for example, the OOI platform that I mentioned, that Coastal Pioneer mooring, they did prototype, I believe it was a methanol fuel cell that was going to be used to power that docking station in addition to the solar and wind. So others are working on those, but our research group is not.
Great, thank you, Rob. If there are any more questions, I encourage the audience to type them into the chat question panel now. And if you get those questions in and we still close early, we can grab those questions and answer them offline, or follow up with you if you would like more information. Carrie, would you like to go into more detail? I know you had a few more slides that you could talk over.
Yeah, I can actually answer kind of a question that we got outside of this chat box. But somebody asked why we decided to focus the rechargeable AUV use case with only using wave energy. And I think that's a great question, so I can answer it here. And there are a couple different reasons. One has to do with how we are going to review and judge the applications. And so, of course, if we had a wave-powered device and a tide-powered device and a current device, it would be pretty challenging to be able to judge those fairly on a consistent rubric. So one of those things is just kind of narrowing it down enough to ensure that our competitors can be successful and then also judge fairly. So that's one piece. But something else I can add is that throughout the Discover competition, which, as you remember, is the first competition, and it had those 5 themes that folks were able to apply into. Part of the reason we did that was to kind of judge and see what was of interest to folks out, innovators and end users and other folks in the ocean observing community. And so that's why we kept the first competition so wide open. We didn't say it had to be wave or tidal or anything. We just said anything that is powered by marine energy and that observes the ocean in some way is welcome. And so we found from that exercise that the majority of our applications were actually wave energy centric. And so, and then we also talked to folks at NOAA, like Michelle mentioned. A huge part of our partnership with NOAA has really been looking to them for subject matter expertise. And through conversations with end users and outreach at NOAA, we determined that wave energy was a good way to focus this first competition. But of course, as I mentioned earlier, we do expect to run additional iterations of this. So certainly none of those lines are, drawn at all. If there's something in the future that would have something beyond wave energy is certainly a possibility.
Thanks, Carrie. We've grabbed a few more questions while you were answering that. Rob, I'm going to throw this question back to you because it's on that issue of fuel cells. Is there, what would preclude the use of fuel cells?
Preclude these. So I think the biggest limitation with fuel cells is where to get the fuel from if you're out in the middle of the ocean. So that's just another thing that would need to be serviced and refueled. We've thought a little bit about ways of using marine energy to generate liquid fuels that could potentially be used in fuel cells in ocean-based applications. But I think the biggest limitation, again, is the source of fuel and how you get it to these far-flung places.
Great, thank you. Our next question is, what are the employment opportunities like in this space? How can one get directly involved in marine renewable energy and ocean observing systems? Are agencies offering jobs in this space, or is this mostly in the private sector?
Thank you for that question. It's a really good one, and certainly one before I started my federal position at the Water Office that was very heavy on my mind. So I'm excited to see someone else is thinking about that. I guess I'll just start by saying, of course, the marine energy industry is still pretty young. So there is, it's not as robustly developed as the solar or wind energy industry, but it is growing every year. And so I would say there are a couple different places to get involved with this. First, I would say, of course, the agencies. Yes, the Water Power Technologies Office is the group that works most on this at the Department of Energy. And so that would be one place to look. We do offer also a couple different internship or fellowship opportunities in our office as well. And so after I'm done answering this, I can chat the links to folks that may be interested in looking at that page. But another really great place to work on this is at the national labs, at our network of national labs. And so the groups mostly engage with this at this point are Pacific Northwest National Lab, where Rob joins us from, and also the National Renewable Energy Lab, or NREL. They both have water groups working on the marine renewable energy space. And then finally, I would offer that there are some private sector companies as well working on this. You can, of course, search marine energy companies. You can take a look at our project map, which is another, better make a list of things I'm going to chat to everybody here. So we'll do the project map and the fellowships page. But the project map shows all the work that we funded since our office has been in existence, really. And so that would be a good place to look and see what kind of companies are working in this area. I would also suggest there is a trade association, actually. It's called the MEC, or Marine Energy Council, I think is what the C is. And it's managed by the National Hydropower Association, NHA. So if you put some combination of those words into your search engine, that will come up, and they actually have a list of companies that belong to the MEC. And so that may be another good place to look for potential opportunities there. And then the last one is also academia. We do have some really wonderful research projects happening at universities across the US. And so that kind of information can also be found on the project map, which I'll chat in here in just a second. But Rob, if you have anything to add, I know you're kind of coming at it from a different angle outside the government, if you wanted to add anything there.
Yeah, I'd also mention that not perhaps employment opportunities, but there are educational opportunities at the National Marine Energy Centers that are throughout the country, mostly on the coast, where they may have opportunities for graduate students and opportunities for undergraduate education as well.
Okay, awesome. We are all quickly popping things into the chat box for everyone to look over. But if there are no more questions, I believe I'm going to wrap this up and give everyone back 10 minutes of their day. And I want to thank Carrie and Michelle and Rob and Charles for finally getting to present this to NOAA today, and reminding everyone they will do another kickoff on the 28th, and to check that out, the link for that on their HEROES website. Any last words, Carrie?
No, I'd just like to thank you specifically, Katie and Michelle, for being so flexible with this, and thank all of our attendees for sticking with us through all the scheduling changes. But we're really, really excited about this prize. Such a pleasure to work with this group. So thank you very much.
Awesome. Thank you, everyone, and have a wonderful day.